Hello everyone, this side Dr. Nitin Sharma, Associate Professor from Department of Information Technology. So today I am going to discuss a topic that is dynamic programming and the Knapsack problem, which is basically in DA, Design Analysis and Algorithm subject in Computer Science and IT branch. So today I'm going to discuss initially about what is dynamic programming, why we use a dynamic programming to solve that kind of problems. And after that, I'm going to discuss about the knapsack problem. So step by step, we can see what kind of knapsack problem is and how we can solve it through the dynamic programming. So initially, what is dynamic programming? It is basically a method of solving complex problem by breaking them down into a sub problems. So suppose you are having a large problem, you can divide it into the small problems, and then you can solve by working backward from the last stage. Like a problem which is having a this is a very large problem, you can just break down into a small sub parts, and once the small sub problems are solved, then you can merge and backward stage to combine them. Okay, and it is basically given by the Richard Bellman, who described dynamic programming. He introduced the concept of dynamic programming as the way of solving problem. What basically dynamic programming is? It is the way of solving a problem. Like a single problem can be solved by the different ways. So either by using the dynamic programming, either by using the greedy programming. So you can solve any problem or in a different way. Okay, where you need to find the best decision one after another. So what is again dynamic programming? It is simply method to solve complex real world problem, like such as a traveling salesperson problem, or say a traveling salesman problem, Fibonacci sequence, stagecoach problem, knapsack problem. Various other applications exist which you are going to solve through the dynamic programming. Okay, so like I'm talking about this traveling salesperson problem. So it is like a salesperson is starting from the one node, and suppose there are different cities. Okay, so that person should visit it at every places. It should cover all the places and return back to the places which they are started, right? Through the TSP, what we have to be find out, we have to find out the minimum cost path which a salesperson is starting from the initial node and traveling from one node to the another node to the another node, covering all the nodes and return back to that position. Got my point? So this is the way you can try to solve the traveling salesman problem by using the dynamic programming. Okay, similarly, other problems like the Fibonacci sequence or stagecoach problems or the knapsack problems, these are the problems which you are going to solve through the dynamic programming. Okay, so today I'm going to discuss about a knapsack problem. So knapsack problem is basically solved either by the greedy algorithm or by the dynamic programming. But in this lecture, because I'm talking about a dynamic programming, so we can see how you can solve a knapsack problem by using the dynamic programming. What are the steps you have to be followed to solve any dynamic programming by the using of dynamic programming to solve a particular problem? So every problem is divided into stages. Each stage is required a decision. You have to take a decision. Either you should make a decision. Okay, and decisions are made to determine the state of the next stage. That decision is reflected to the next stage. The solution procedure is to find an optimal solution at each stage for every possible state. Okay, the solution procedure often start at the last stage and works its way forward. So this is the steps which we are going to follow when we are going to solve the knapsack problem. Okay, so before going to solve a knapsack problem, we have to understand what is knapsack problem. So as you can see, there is an example I am introducing here. Suppose, for an example, you are a mischief child campaigning in a wood. You would like to steal item from other campers. Okay, so this is a small things which can do by any student, but you can only carry so much mass in your knapsack or your bag. Okay, you can you see 7 items worth stealing. Each item had a certain mass and some monetary values. how do it maximize your profit so you can buy more video game later. So like this is the knapsack, or we can say that the bag, and bag is having a limited capacity. There are so many things are available in the camp which is having a different students. So how a child can like get or store in that particular bag? Okay, for this you can see an example for this. If you can see here, the value and mass of each item is given there. Okay, and you should put the maximum item which either you can get the maximum profit store into the particular bag. So subjected to mass constant of knapsack is 15 kg, so that the size of the capacity of the bag is 15 kg here, and these are the item which is given here, and every item is basically represent the size, or we can say that the mass. So 2 kg, 2 kg, 3 kg, 3 kg, 3 kg, 4 kg, and the parallelly also given the profit. So profit is like $1, $2, $2, $3, $4, $6. So it is totally depend on the items. Like a same item, like the same mass, like you can see 3 kg, 3 kg, 3 kg. So the item is having the same mass, but the profit is different, either $2, $3, $4. Okay, so it is totally depend on that student to find out okay, how we can select the item which we can get the maximum profit. Either we can select all of them, or either we can select a 4 kg and 3 kg and 4 kg $8. So how you can choose the items which complete the bag for about 15 kg and you can get the maximum profit. So being a smart kid, you apply a dynamic programming here. Either you can choose the options, you can just apply the dynamic programming and get the result. Okay, so for initially, if I can see the whole thing here, so if I can choose these items and I can just left these two items. So if we can add 2 plus 2 is 4, 4 plus 4 8, 8 plus 4 12, 12 plus 3 is 15. So my bag is full if I can select these items, this one, this one, this one, this one, this one. If I can select these 5 items, so my bag is going to be full. Yeah, that means the 15 kg bag is full, the knapsack is full. And how much profit I can get here? I can get here like 8 plus 6 plus 4 plus 2 plus 1. So 10, 20, 21. So I can get here $21 if I can choose this. Either we can choose this item, I can just neglect this one. If I can cross this one, I can select this one. So my profit is going to be $20, which is less than $21. So my approach is that we have to be select that items. My profit is going to be the maximum profit, right? So I'm going to get the maximum profit through the knapsack. We are going to apply the dynamic programming. Got my answer? So this is basically the generalization of a problem, or you can understand what is the problem is, what kind of solutions we want, and how the item is selected, right? Now we can go through the numerical portion. So you can see this is a numerical portion. I am going to explain this, how you can solve this. Okay, so in this example, you are having here 3 things. First is profit, like 1, 2, 5, 6. P is basically representing the profit, and W, small w, is representing the weight. So the item is 4 here, like 1, 2, 3, 4. These are the item 1, 2, 3, 4. So these 4 items, and every item is giving a simultaneously profit and the weight. So the first item is profit is 1 and weight is 2. Second item, profit is 2 and weight is 3. Third item, the profit is 5 and weight is 4. And the fourth item is profit is 6 and weight is 5. Now the third thing which is given by the problem, that is capital W, which is 8, which is basically the bag size, or we can say that the knapsack. Understood my point? So these 3 things I am having here. Now I am going to solve this. So initially what you have to do, you have to create a table. and the number of column you have to be created, like whatever size is given for the bag, you can just create a number of columns plus 1. Suppose the weight is 8 here, so I am taking here the 9 columns initially from the 0 and 1 2 3 4 5 6 7 8. So this is the weight, and this is basically the weight table, or we can say that the profitable table. Okay, and on the left hand side you can see here I am writing the profit and the weight, and weighted is already a shorted form, so we can write it here right directly. If weighted is given in an unshorted form, you have to be write in a shorted form. Okay, so I am written here the shorted form here. Okay, so one by one, and here I am writing the object. Zero object means that there is no object here. I am not going to select any object till now, so I am writing here 0. First object, second object, third object, fourth object. How we can fill this? So initially, when you did not select any item, okay, so what are the capacity fill of that particular bag? 0, because the bag size is 8 and no item you put till now. So what is the capacity fill of that particular bag is 0. So we have to be fill here 0. Got my point? Initially. Next is weight is 2. When I select this object, the object 1, when I select this object, the weight is 2. So that means the weight of 2 is fill, right? And when this item is selected, the profit is 1. So the profit is 1. So you have to be right here 1. Okay. Again, I am repeating this point. When I am selecting this object 1, the weight is 2. So we have to be put some value on 2, and the profit is 1. So we have written there 1. So the bag capacity 2 is full, and the capacity, when the capacity fill is 2, the profit is 1. What is the previous value? That is the repeating from the previous one. Why? Because when there is no item in the bag, so we have to be right here 0, obviously. So this one is also 0, you can write here. Okay, and 1 there is no item which is having a weight of 1, so we have to be right here 0 1. No other item is selected yet, because I am selected only the first object, and the object's weight is 2, so we can put here 1. What is the profit of that particular bag in the entire bag? So entire bag is 8 kg, right? And fill only 2 kg, and you are having currently profit is 1. So the profit is 1 at the entire row. Got my point? Now, second item. When I am going to select this second item, the weight is 3. Okay, so we are going to be weight is 3. Okay, so this 3, and the profit is 2. We can write here 2. It should be greater than the previous one. If I can include anything, so we have to be write the increasing values. So we have to be write here 2. What are the previous value? You can just copy paste from the upper value. Got my point? Next, when you are selecting this value, you have to be try to combination with the previous weight. Like initially you are having only the second item in your bag, so you are having a 2 profit at 3 weight, right? But if you can combine this 1 or 2 object, what will happen? 3 plus 2 5. So the capacity of the bag full the 5 kg. And what is the profit you can get here? When you collect these 2 items into the bag, the weight is becoming a 5, so profit is going to be 3. So we have to be right here 3. What are the previous value? Previous value you can come like 2. And what are the others value? Others value you are repeating them, because when the 2 item into the bag, the size of the capacity fill is 5, the profit is 3. So the other 3 values are the same, like 3, 3, 3. Understood? So this is the process. You can repeat it for the another item, for the another item, till the all the items should be covered here. Let's see the another item. Third object. If we can include this third item, the weight is 4. Okay, so we can go for the 4 weight. This one. What is the profit? Profit is 5. So we can write here 5. which is greater than the 2. Okay, so we can select this item 5. What are the previous value? Previous value you can just copy paste from the upper one. Got it? Now what will we do next? We have to make a combination with the other items. Suppose you are selecting the third one. Now you can try with the previous items. Okay, so if we can combine with the second object, so 4 plus 3 is 7. So 7, yes, we have a capacity. We can store these two objects. So 4 plus 3 is 7 and the profit is 7. So we can write here 7. Okay, next 4 plus 2, 6 and the profit is 6. We can write here 6. Okay, we can combine all three items. Maybe we can store all the three items here. So 4 plus 3 is 7, 7 plus 2 is 9. It is not possible because my bag size is 8 and the addition of all three object values, the weight, which is becoming a 9. So I'm not going to store this. So this item we can store at 4th, which is written here 5. When we combine this 3 or 2, the weight is 4 plus 3 is 7. So we can write here the profit is 7. When we write 4 plus 2, 4 plus 2 is 6 and the profit is 5 plus 1, 6. We can write here 6. What are the remaining value we can put here? So the remaining value is we can write the 5, which is taking from the previous one. And what is the other values forward? Like these three items or the two items are stored into the bag and the remaining space is free. So how much profit in that particular bag? I am getting here this profit. Got my point? Similarly, we can do for the next one. Fourth object, the profit, the weight is 5 and the profit is 6. We can go here 5 and the profit is 6. Okay, when we weight is 5 and the profit is 6 here. Got my point? Now what we have to do? We have to be combined with the previous objects like the previous one. Okay, so we can create one. First 4 plus 3, 5, fourth object plus third object value. So the weight is 5 plus 4, that is 9. But we are having only the capacity of 8 kg. We cannot combine together. Now 5 plus 3, 5 plus 3 is 8. Yes, we can consider these two items, this one item and this one item. So 5 plus 3 is 8. So 6 plus 2 is 8. So profit is 8. 8. Okay. Next 5 plus 2, 5 plus 2 is 7 and the profit is 6 plus 1 is 7. So 7 to 7. Okay, so I can make all the combination like 5 to 4, 5 to 3, 5 to 2. Can we combine all together? Let's see. 5 plus 4 is 9, 9 plus 3 is 12, 12 plus 2 is 14, 14. Can I consider all 4 of them? No, because my bag size is 8 and the addition of all the object weight is going to be 14, which is larger. So I'm not able to store that all object into that particular bag. So what we have to do here? We just neglect it. What are the other values we can put here? Just copy paste. The previous one is coming from the previous row. This one is also coming the previous row. So this is the profitable table which is created here. I am going to get here. And what is the maximum profit? When I selected the items, the maximum profit I can get here, that is 8, which is coming in the last cell. So I'm getting here the profit is 8. Now the question is, what are the object which we are going to be select to get the maximum profit, that is 8 here? How we can get the object selection from this table? Okay, let's start from the last cell. Last cell, the value is 8. So the profit we can write here. Profit is 8 here. Okay, we can just write here the object x1, x2, x3, x4. Okay, this value is coming from the previous row, or this value is available in the previous row? No. That means this object is included, that's why the value is coming 8, right? Suppose there is value 8 is here and again 8 is here, that means when the object is introducing or including, you have to get some profit. So when you get some profit, you have to increase the value. So like here the value is 7, when you include the object, the profit is increasing 8, that's why the value is differ. So 8 is coming from the previous one, no, 8 is here, so that means this item is included, the fourth item, so we can include this item. Got my point? We have written there 1, either we can write here 1 or 0, either you are selected or not selected item. So when we are selected 1, not selected is 0, representing 0. Okay, what is the profit is given by that object? 6. So we can just minus this profit, that is 8 minus 6 is equal to 2. So when include this one, we get the profit 6. Now what is the profit remaining here? That is 2 here. So we have to be search 2 in the previous row, because this row is completed. Now 2. So 2 is here. Can 2 is coming from the previous row? Yes. 2 is also available in the previous row. That means if I can see here, 2 is here, and if I include this item, 2 is here, that means this item is not going to be included here, right? So what we have to do, we are not selecting this one. We are going to be the third row. 2 is here, yes. This 2 is coming from the previous row? No, there is no 2 in the previous row. So 2 is here. That means this item is going to be selected. What is the item? Item is second object. Second object. We are going to be select here. Okay. What is the profit? Profit is 2. What is the remaining profit? Remaining profit is 2. So we are getting here 0 profit. That means these are the items. What are the remaining items are there here? You have to put here 0. So this is the answer. If you are going to be select the second item and the fourth item, you can get the maximum profit, which is nearby or which is basically equal to 8. Got my point? So this is the way you can solve the knapsack problem by using this profitable table. Understood? Try by yourself one more time. I'll give you a homework for this one. Okay. And you can see here, this is the profit. Object 1 is 1, 2, 2, 3, 5, 4. Profit, weight, and this is the back size. Whatever the back size, I have created this one table, and you can see. So initially what you have to put, I can just quickly do this 0, 0, 0, 0, 0, 0, and this one is 0, 0, 0. When I included first item, so first item when I included, the weight is 2 and the profit is 1. The previous value is here and all the values are repeated here. Okay. When you are included the second item, the weight is 3, profit is 2. The previous value is repeated and the all, and if I can combine here, 3 plus 2 is 5. 5 profit is 3. 5 profit is 3. All the remaining I can write here. Again, the last item is 3. The weight is 4. Profit is 5. So we can write here 5. We can combine 4 plus 3 is 7. Not able to eligible here because the maximum back size is 6. 4 plus 2, 6. The profit is 6. So 6 is 6. What are the other values? You can just repeating them. So the maximum profit is 6. How the item is selected? I can write here x1, x2, x3. Profit is 6. This 6 is coming from the previous row? No. So we can include this item. So third item, we can select this one. What is the profit? 5. So 6 minus 5 is 1. We can get 1 in this row. Can I, is this coming from the previous row? Yes, it is also available in the previous row. So that means this item is not going to be selected here. 1 is here. It is coming from the previous one? No. The previous row is having a 0 here. So we are selecting this item, the first item. Okay. So the first item, the profit is 1. We can select here 1 minus 1 is 0. So that means we are going to be select the first item and the third item. Okay. So this is the way you can solve the knapsack problem by using dynamic programming. Thank you so much. In the next class, we will discuss a more complex topic from the